Okay, hi. In this class, we are going to discuss the vector triangle, and I hope that you have gone through the text that has been supplied before this lecture, and mm, it'll help if you go through that text at least one. It's not more than 20 minutes or 30 minutes read, right? So let's get started with vector triangle. Okay, so the accident that you saw in this course in the video that I gave you earlier, what actually happened in that? All that happened was the airplane was to go from Alaska to a place in Korea, and they experienced a lot of winds from the south, and they somehow landed up over Russia, and the aircraft was shot down. So we are going to see how all this happened in basically simplify it with simple mathematics, and we have already seen in the foundation course the vectors and triangles and how do we resolve vectors. So this will is just an extension of that. There's nothing much more in it. Okay, so let's get started with vector triangle. Okay, let's say you have a plane and you're flying in this airplane and the north is as indicated. So, and you're flying on a direction of, let's say, 030 degrees. Okay, so this is north and this is about 30 degrees from north. So your direction is 030, and you're flying with a speed of, let's say, 100 knots. Okay, now this is called your heading, and it is represented with one arrow. Okay, and you experience winds from the right. Okay, you experience winds from the right, which is shown by this orange arrow, and it is represented with three arrows. Okay, it's represented with three arrows, and let's say you're experiencing a wind velocity. In this case, let's say it's coming from the direction 090. So this is north and it is coming from 090. So whenever we say wind velocity, the direction that is specified with it means from which direction the wind is coming, and when we say our heading, we mean which direction to we are going, which direction are we heading. And when we say about winds, it is from which direction winds are coming in. So let's say you're experiencing winds of 090 from this direction, and it's about, let's say, about 40 knots of winds. Okay, then what is going to happen is that your aircraft, your final footprint on the ground is not going to be 030, because the whole air mass is moving you to the left. The whole air mass is moving to the left, and the final track on the ground, the final footprint on the ground that you will follow is called the track, and it is shown with two arrows. So this is track, this is track, which in this case we are saying that it's going to be 360. Okay, now if you notice, and what is going to our speed? Our speed is going to be the vector sum of our true airspeed. So on this side is heading and true airspeed. This side is wind velocity, and in this side we get track and ground speed. This is the speed at which you are traveling on the ground, or you are covering distance, and this triangle is called the wind triangle. And the difference between the track and the heading is called drift angle. Why is it called the drift angle? Because this is the difference between where your nose or your aircraft is pointing, and track is the actual path on which your aircraft is traveling. So how is your aircraft actually traveling? Your aircraft is actually traveling like this. Okay, your aircraft is actually traveling like this. So what does it mean? This means that let me clear off all the ink. Okay, this means that let's say we started from Mumbai and we wanted to go to Lucknow. Okay, and so this should have been our heading, and we experienced strong winds from the left. So we are not going to reach Lucknow if we continue on 030. Okay, we are going to land up over Jaipur from Mumbai if we continue on a heading of 030. And if we want to go towards Lucknow, then we'll have to point our aircraft somewhere here. We will need to point our heading somewhere here so that the vector sum of my heading and TAS with that of the wind velocity matches my track to Lucknow, which should be about 030. Okay, so I'll have to offset my direction to the right depending on the drift that I'm experiencing, right? So we'll see how to calculate all this during the later part of this video lecture, but for now this is enough. So there are two aspects to it. One is that your wind will give you a drift, that it will make you go left or right, and secondly it's going to change your forward speed, because depending on whether it's coming from the wind is coming from front or it's coming from rear. If it's coming from rear, it's going to increase your speed, and if it's coming from front, it's going to reduce your speed. Okay, so let's see a few examples of that. Okay, let's say in this example the wind is not exactly from the right. Okay, it's coming from a direction. Let's say if you are going on this 030, let's say the wind is coming from a direction of 050, right? So there are two effects that wind is causing. That is, it is making you drift left, which is because of this component, which is called crosswind. Crosswind, and this makes you drift. This makes you drift. And the second component of this wind velocity vector is the headwind or the tailwind component. Okay, and this component is called the headwind, or if it's coming from behind, it's called tailwind. And this component, it changes your ground speed. It changes your ground speed. Okay, so in this case, if you see, in this case what is happening is your final speed, this was your ground speed, right? This was your track vector, track and ground speed vector. Now if you see, your ground speed has reduced from what was your TAS. This line is bigger than this line, which means that you are experiencing headwind from the front. Okay, so this line, your TAS is more but your ground speed is less because you're experiencing a headwind component. Okay, let's take another example. Okay, in this case you are heading 030 only, but you got a wind from your tail. Okay, that means you are having a wind of let's say if this is 360, you're getting, your wind is coming from 240 direction. Now you see what has happened. The crosswind component, this is the crosswind. It is making you drift right, and you have got a tailwind component. This is the tailwind. The tailwind component is making you go faster, and that is why your ground speed is more than your TAS. This is your TAS. This was the TAS. So the length of this vector is much more than this vector because you have got additional component of tailwind here, right? Okay, so this is what in short what it means. Okay, so let's try to solve a composite problem that will involve all the things that we have discussed in this module of basics of navigation. So let's say we have been given this kind of problem that our speed is given, our height is given, heading is given, we have been given wind velocity, we have to find out track, we have to find out the true heading, we have to find out magnetic heading, we have to find out the TAS, we have to find out the ground speed and the time that will take to cover a distance of 82 nautical miles. Now, you're not going to get these kind of problems in your exam. You'll get it in bits and pieces. That means your problems could involve only this portion, okay? It could involve only this portion, or it could involve TAS and wind velocity computation, or ground speed given, distance given only. So you could have different components within this problem that you might get in your exams, but we'll try to solve it all of them so that we get the flow of how things work out, right? Okay. So let's say how we'll do this. So we first start from, let's start from heading. You can start from anywhere, right? Now heading, compass, deviation given, magnetic heading you have to find out, variation is given. So this portion we will do by using CDMVT. Okay, so using CDMVT, if I'm going from C to T it is plus east minus west. This is 1 degree west, so minus, so this will be 319. And now it is 11 degrees east, so I add 11 degrees to 319 and I get 330. This one part of the problem is solved. Okay, all right. So this was only of the problem of magnetic variation and deviation. Okay, now to solve the wind triangle, we will have to first find out the TAS. Okay, how do we find this out? We find this out with the help of flight computer. So we have been given 111, 4000 and -5. So let's try to solve it here. And so we said we are going to use this part, that is air speed correction. We are going to use the air speed correction because we have to find out the TAS. Okay, so what we do is we will align 4000 on this window against temperature given to us was -5. So that's what we will do. So we are going to align 4000 feet here with -5. Okay, let's align. Okay, so this is 0, this is -5, and this is 4000 feet of pressure altitude. Okay, so we have aligned now 4000 with -5, and let's read what will be our TAS for a speed of 111. So what does it say here? It says set pressure altitude opposite degrees Celsius in the window, opposite CAS on inner scale, read TAS on outer scale. So that's what we are going to do. So uh, if CAS and RAS is not separately given, you take all of them as same. Okay, so we are going to read against 111, and what do we read here? 115, 116.25. Okay, so let's see this, and now we have got a TAS of, so we'll round it off, we get 116. Okay, now that we have got the TAS, wind triangle is nearly complete, and we just have to find out the track and ground speed. So let's draw it. It's a good idea to draw it because it helps you to visualize. So we are heading 330. That means if this is north, we are heading 330. Okay, so we are heading 330 and at a speed of 116 knots of TAS. So this is heading and TAS. That is your true air speed. Okay, so now let's draw the, okay, I drew it on the wrong side. Okay, so okay, fine. So now wind velocity is 220. That means it is coming from somewhere here, right? So we join the tail of the wind here at the head of my heading and TAS. So it will come to somewhat like this. So this is 22030. This is 330 116. All that I have to find out now is track, which is this one, and ground speed. So in this in any vector triangle, if two of the vectors are given, you can always find out the third one. Okay, so let's see how do we find out this track ground speed using the flight computer. What we need to remember is heading 330 and 220, 30 knots is the wind. Okay, so okay, so we will go for this on to the wind side. Okay, first thing we will set is the, okay, let me note down these values. We have 3,220,30 is the wind, and 330 116 is the heading and TAS. Okay, all right. So first step, what we'll do is we will set the wind. That means we will align this with 220. Okay, 220, and the wind is coming from this direction. Okay, so we are going to mark it. So I just, you can place this anywhere on up or down, wherever, doesn't matter. So for ease, I'll put it on 100. Okay, you can put it anywhere, it doesn't really matter, you can put it on anywhere. And 30 knots, so 10, 20, 30, I put a dot here. Okay, now what I've basically done is I have marked my wind vector. Okay, this is my wind vector, I just marked it on this. Okay, that's all I have done. Okay, now next we are heading on 330 and 116 knots. Okay, so what we are going to do is we are going to move this to 330. You move this to 330 and we take it to 116 knots at the center here. Okay, so here, this is 116 knots. Okay, so I moved it here. Fine. Now, do you see that by doing this, it has solved my vector triangle graphically, which means that now my heading and task is here. Okay, this is the vector of heading and task, and this is the vector of wind. This is the wind vector. Now I can just read off my track and ground speed from this third vector. Okay, so I'm just going to read it off. Okay, so what does it say? My speed is coming to about 116, it's coming to 130 here. Okay, so 130 knots is my ground speed. And what is my track? Okay, my track is, you see here it's written 10. Okay, so that means 330 plus 10, 340, and this is 1 2 3 4 5, it's all 5 degrees, so 1 and 2, so this will be 342. So I have got a value of ground speed equal to 130 knots and track of 330, which I got, the 330 I got from here. Okay, and about 12 degrees of drift. So it will be 330 plus 12, okay, which is equal to 342. So I got my answer of ground speed 130 knots and track of 342 degrees. Okay, this is what I have got. So now I'm in a position to complete. So ground speed I got of 130 knots, okay, and track I got of 342. Okay, now I have got my ground speed. Okay, just let's make sure that it's making sense, because I had tailwinds, so my ground speed should be more than my TAS. Okay, so I got my TAS at 116, my ground speed is more than that. That means I have tailwinds, so it's making sense. And I have winds from the left, so my track should be to the right of my true heading, which is 342, which is right of 330. So it's making sense. Sometimes what happens, we make silly mistakes, and we must do this sanity check to find out that things are making, at least they're making some sense. All right, now we just have to find out time. All right, this you can do with a simple calculator, or you can do with the flight computer also. So let's try to do it with the flight computer. And for this, we go on the side rule side. Okay, all right, and to find out the time, we will set the 60 mark against the speed. So our speed is 132, so we are going to set 130 knots, sorry. So we'll put 60 against 130 here. This is 60, this is 130. So I marked it against 60 against 130. And now I'm going to read off the value. Look here, it says here how to find out. Okay, set arrow against knots and read distance outer to time inside. Okay, so distance outer to time inside. So I have to find out 82. Where is 82? Let's find out. 82 is here. 82 is here. Okay, and I am going to take 35, 36, 37, 38 minutes. This is 38. This is 38. 38. So now this portion is also solved, and I'm going to take 38. So we have completed this entire problem using the flight computer and our knowledge of CDMVT. Okay, just to remind you, you might get it in portions. Okay, you'll get, sometimes you'll get this portion, it's only, or you might get track, wind velocity, given the true heading and TAS, find out only the wind, or you could get, most of the times you sometimes get such simple questions also, but make sure that you don't make mistakes in this because they're too simple to be made mistake on. All right, so that's about for the wind triangle. There's a full exam, practice exam with all the solutions, which is posted for you. And once you have completed the entire course module, you must take this full exam as well, along with the tests which have been given for different smaller courses as well. And that will complete our module on basic navigation. And next we are going to move on maps and projections. Make sure that you take all the tests, okay, and you name your you enter your name correctly in those tests. Thank you.